Bienvenidos, Ushamdi, and welcome, CTS230, Section 841 students, for the first 8-week term of the fall 2017 semester at Anne Arundel Community College. This is the Networking 3, or the Cisco Networking Academy Scaling Networks V6 course, and this evening's video tutorial and solution set is going to be on Packet Tracer Activity 4.2.1.3, where we're going to be configuring Ether channel. So let's go ahead and take a look at the activity. And it's actually very straightforward. We actually have 3 switches that are in a triangle, and we've got redundant links running between all of the switches. And so as a brief refresher, remember that the problem that Ether channel solves is that we have multiple ports here that are going to be blocking due to spanning tree. And spanning tree is going to be preventing loops here in our layer 2 domain. And so in order to take advantage of both of the links that we have interconnecting some of these switches here, and remember, spanning tree is going to be blocking somewhere in our layer 2 topology here, because even with a single logical interface, our port channel interface, spanning tree still sees that we have this loop here, right? So it's going to be blocking on one of these switches one of the port channels, but it gives us the advantage over what I described in the video where I talk about layer 2 traffic engineering. So in a typical layer 2 environment where you have an access layer switch, and then you've got distribution layer switches, we'll say D1 and D2, there is a very good chance that you have multiple uplinks here. And so if we've got multiple uplinks, do we want the uplinks to all be used, or do we want the uplinks to be blocked, right? Or to have uplinks that are sitting there not being used. And so remember, I gave the example of 2 switches, two switches that were connected with 8 connections. Actually, there were 16 total connections. But what we saw was that if that was the root bridge, because of the sender port ID being the lowest on this port, which was FA 1033, this was the root port, and of the 8 ports, that is the only port that was in the forwarding state. I apologize, my pen is running way behind what I'm actually drawing here. So that was the only port in the forwarding state. So we had a single port doing all the forwarding with 7 other ports sitting there doing nothing. And so then that is where the conversation of Ether channel, and that's the universal signal there for these are bonded together or in the same port channel. And again, there's multiple synonymous ways to refer to Ether channel. Sometimes you'll hear it referred to as a lag, a link aggregation group. Other times you'll hear it referred to as a port channel. And we see that here, port channel 1. And that's typically how you refer to the interface that's created, the logical interface that's created from, the logical interface that's created from the physical switch ports that we're going to bundle together. And then other times you'll hear it just referred to as an Ether channel. And one of the confusing things is that when we run some of the commands, you'll see that some of the commands use Ether channel as an option for a keyword. Others use port channel, and some commands use both. So let's go ahead and dive in here and start configuring. So that way we can optimize this layer 2 topology. So we're going to be doing PAgP and LACP. Now, key things to remember is the Port Aggregation Protocol, or PAgP. Just like ISL, the inter-switch link trunking encapsulation, PAgP is Cisco proprietary, but we should be familiar with the 2 modes that PAgP is going to use. It's no surprise that PAgP uses desirable and auto. Just like Cisco's dynamic trunking protocol uses desirable and auto, right? So the mode names will be the same. And you'll also see that the behavior is very similar as well. That in order for the Ether channel or the port channel interface to come up when using PAgP is that one of the sides has to be desirable, right? If both sides are auto, it's not going to simply negotiate itself to an access port. That port channel interface simply will never come up. And I'm actually going to be demoing this on actual physical Cisco switches. So let's dive in here. So we're going to configure the port channel. Well, actually, it wants us to do some host names first. Now, unfortunately, we still have this sort of CLI challenge here where the text is extremely small on the switches. So I will definitely MC things. So we're going to go from user exec with that greater than sign to privilege exec with the pound sign by typing enable. And then let's go ahead and get into global config where we're going to say host name, and this is simply switch 1. So now that I've done this configuration, and I tell you what, I love the fact here that it says, you see this note right here, and I'll read it because it's also very small. It says, if the ports are configured with dynamic auto mode, and you do not set the mode of the ports to trunk, just like we talked about in the previous video, the links do not form trunks. They remain access ports. Remember, the default mode, and here it says the default mode on the 2960 is dynamic auto. That is true. If this was a multi-layer, 3560, 3650, 3850, 3750, it is also dynamic auto. So let's dive in here on switch 1. So between switch 1 and switch 3, we're going to be configuring PAgP. And again, I know by looking at that command right there that's going to be PAgP because the modes are auto and desirable, just like the dynamic trunking protocol. So it says add ports fast Ethernet 0, 21, and 22 into port channel 1. But before we do that, let's make sure that we check to see what is the status of those ports. I'm going to say do show interface fast Ethernet 0, 21 switch port. And we see that the encapsulation is set to .1Q, and we see that right now it's dynamic auto, right? Remember, if both sides are auto, it's going to negotiate to what? A static access port, and that is not what we want. We want these to be trunk ports. So let's say do show run interface fast Ethernet 0/22. Whoops. Not show run. Do show interface fast Ethernet 0/22 switch port. And we see that it's the same thing. Dynamic auto is the default dynamic trunking protocol mode, and the encapsulation is .1Q. So if I say interface range fast Ethernet 0/21-22, and we're going to follow this other note here. It is always recommended, and I highly recommend that you shut the switch ports down that you're going to be using in the bundle in order to, and I apologize there, I said switch instead of no shut, that you shut these trunk port or these switch ports down before you start to do your configuration work. That way, you bring everything up at the same time. So I said no shut, I apologize. I say shut down, and we bring the ports into the shutdown state, right? So now it's here that I'm going to start my work. So I want to make these trunk ports switch port mode trunk. And it's important to do this before you configure the Ether channel, because if I left it as dynamic auto and as an access port, I would run into issues if I tried to change it later, right? And I'll show you what that looks like when we get on the real Cisco switches. You want to make sure you get this right here so that you don't have to destroy the port channel interface, or I should say go in and reconfigure everything. So I say switch port mode trunk. I'm going to say switch port no negotiate because I'm hard coding it as a trunk. The end cap was already 802.1Q. That's our only option on the 2960. So I don't need to worry about that error that you see, the auto error, right? The encapsulation mode set to auto. We don't see that because there is no negotiation, no auto negotiation of the trunking encapsulation. So now that I've got it set as a trunk port, I'm going to go ahead and say channel, I'm sorry, we're going to go ahead and say channel group 1 mode. Now, here's where we want to use desirable, right? The desirable says it's going to actively try to negotiate the Ether channel PAgP link. So channel group 1 mode, desirable, and you can see it says creating a port channel interface, port channel 1. Now, it's typically here where going forward, all configuration that you do to the port channel should be done under the port channel interface. And the reason for that is that it pushes down the configuration to all of the member links. And the reason that that is so important is you don't want to go into one of the links, change something, and then forget to change it on all of the member links. You could end up with inconsistencies on the member links, and that's something that you definitely want to avoid because you could end up with unexpected behavior when you have some configuration on some of the members and some configuration on others, right? Especially when we start to talk about manually pruning VLANs off of the trunk ports, right? So if I wanted to do that, I would go to the port channel interface to do that, and then it pushes that down to the member interfaces. So for switch 1, we've taken care of fast Ethernet 21 and 22. Let's come over to switch 3, and we're going to do the exact same thing. So over here on switch 3, I'm going to go from user exec mode. From user exec mode to privilege exec into global config with configure terminal. We'll set our host name to switch 3 or just S3. And then I'm immediately going to go into interface range fast Ethernet 0/21-22. We're going to shut these ports down. And then I'm going to say switch port mode trunk, switch port, and then channel group 1, because that's going to give us the port channel, and I should probably check, it is port channel 1, just to double check real quickly, mode desirable. So this is going to be forming a PAgP port channel logical interface that contains multiple physical interfaces. If I say do show ether channel summary, we can see here, from the output, I've got the 2 interfaces that make up group 1, right, or port channel 1, PO1, and we see that it says S and D. So this is awfully small. So now is a good time. Let me transition over to some real Cisco switches here. We're going to be using DLSW01 and 02. So if I was to say show IP interface brief, we should see that 33 through 48, these are all up. So we're going to work with the first, I'll just grab 4. I'll say 33 to 36. So if I go into global config, with the configure terminal command, I say interface range fast Ethernet 1/0/33-36. And here, again, I want to shut these guys down before I start to do any of the configuration work on them. So what are we going to say first? Well, I'm going to say channel group 1 mode desirable. Right? Now you can see it creates the interface. Now, what didn't I do? Yeah, I didn't make these trunk ports. So let's see what happens when that's what we do. So over here on the partner switch, we're going to go into privilege exec into global config, interface range, fast Ethernet 1033 to 36. We're going to shut them down, and I'm simply going to say channel group 1 mode desirable, right? So do show ether channel summary, right? Shows me the 4 ports that are my member ports, and we have a capital D. And again, that capital D means that that link in the ether channel group is down, right? Again, over here we see SD, S standing for switch port, right? R standing for routed port, because even though it's outside the scope of the course, quickly discuss, you can do layer 3 ether channel, right? So if you have a layer 3 link between these switches and you wanted to improve or increase the available bandwidth, which may result in an increase of throughput across your enterprise, you could do a layer 3 ether channel as well. But we're interested in the layer 2 ether channel. So S for switch port, D for down. So we know we've got an issue here. So I'm going to say no shut. And we're going to bring those interfaces up. And then we're going to come over here and we're going to say no shut. And let's see what happens. So the interfaces come up, and what we're waiting for is a line protocol, or I'm sorry, an interface link up down message right here. Line protocol, port channel 1, change state to up. Well, that's fantastic. So if I say do show interface trunk, do we see the port channel as a trunking interface? We do, right? And there it is. And it shows up by itself. Now, what happened to interfaces fast Ethernet 1033 to 36? They no longer individually list themselves out here. And the same is true if I say do show span. And remember, we configured these already individually as trunk ports. And take a look at what happens when it lists everything out. So this is the non-root bridge. Same switch, same connections as the video on layer 2 traffic engineering. But what we see is that the cost has dropped. So with 4 fast Etherlink links in an Ether channel using PAgP, our cost drops to 8. So you can see that it's not a set cost that it's dropping here. Because how did we get from 19 to 8? The difference there is 11, and we added 4 links. So you can see it doesn't evenly work itself out. But Spanning Tree and iOS is smart enough to realize that I've created a single logical interface that consists of 4 physical interfaces, and therefore that single interface clearly is going to be preferred because it consists of 4 physical interfaces, clearly going to be preferred from a spanning tree perspective and a forwarding perspective over individual fast Ethernet interfaces. Now, this is what I meant. Let's go ahead and say do show run interface fast Ethernet 1033. And that's what we see. That's what we have right now. They got that channel group 1 mode desirable, switch port no negotiate, switch port mode trunk. What about fast Ethernet 34? Identical. 35, identical. 36, identical, right? So now I'm going to go into interface port channel 1. And I'm going to say switch port trunk VLAN, allowed VLAN, and let's say we're only going to allow 10, 20, and 30, right? So now what happens, and of course VLAN 1 goes down, so let's go ahead and say 1, 10, 20, 30. We'll keep VLAN 1 up here. So now what happens when I say do show run interface fast Ethernet 1033? Well, that's interesting because remember, I didn't apply the switch port trunk allowed command to that individual interface. I applied it to the port channel interface. So take a look at what happens. It auto-magically pushes it down to every single, sorry, I wanted 35 there, to every single interface in the Ether channel, right? And that is what you want. You must maintain consistency. It is critical to maintain consistency and the sameness of the configuration on the physical member interfaces. And the same is true, let's put a description in here. This is my port channel interface. Does this work? And let's say do show run interface fast Ethernet 1033. Where is it? What happened here? 1034, 1035. Does the push the description down? What about a do show run interface port channel 1? So the description is something that doesn't automatically get pushed down to every single interface. And so again, it's because the description, right? And so the question is why? What's the logical question here? Well, why didn't that work? You just told me it's going to push it down. And so the reason it doesn't push it down to all of the member interfaces is this reason. Does the description have to match for functionality? And the answer is no. The description can be whatever I want it to be. What if I wanted to put down a different description under this interface? That's okay. But what I can't do is I can't put in a different trunk allowed VLAN command, because that will then cause inconsistent results. Because then I have a single member interface that is not allowing, either by intention or by mistake, it's not allowing the full same set of VLANs across its individual physical port. And what happens if we do that? Interface fast Ethernet 1033, and I say switch port trunk allowed VLAN 10, right? It allows me to run the command, but now take a look at exactly what goes down here. Cannot bundle. So fast Ethernet 1033 is not compatible with 34, and it gets suspended. So now when I say do show ether channel, and I got to put the C in there, I think, ether channel summary, take a look at what happens. We have a capital P here for 34, 35, and 36, and that capital P means bundled in the port channel, which means we're good. You want to see the P's over here. And you want to see SU, because that means it's a layer 2 switch port, and it is up. We are operational. We're in use. But that lowercase s right there. So that's one reason that you could see a port being suspended. And again, it's suspended. We're not using it. And that's a problem, because the whole idea, the whole premise behind configuring multiple physical interfaces into an ether channel bundle is so that we can load balance and take advantage of all of the traffic going across all of those links, or at least having the possibility of the traffic hashing and spreading out and leveraging all of the physical links in this individual logical interface ether channel bundle, right? So let me go ahead and pull that command out, say no switch port trunk. And so of course, right, we want to maintain things. It still says it's not compatible because the other ones have that switch port trunk command to allow the VLANs. And to make sure that I do not spin my wheels here, let me grab that so that we get the exact setting and put it on there. So again, hopefully that demonstrates the criticality of the functionally required commands, right? Why you want to enter those functionally required commands on the port channel so that they auto-magically push down to the member interfaces. But that with the description, it's not really necessary, right? Because does the description have to be on the port for the port to function properly and on both sides? No, it doesn't, right? So you've got flexibility there with non-functionality type things like the description. So let's transition back to our activity here. And let's bring up those interfaces. So on switch 3, we'll go from user exec to privilege exec into global config, interface range, fast Ethernet 021 to 22, and I'm going to say no shut. And then we're going to go on to switch 1, and we're going to get into, we're in user exec, enable to get to privilege exec, configure terminal into global config, interface range, fast Ethernet 0/21-22, and we say no shut. And you can see, right, it comes up much quicker here because this is packet tracer. You saw that it did take it a few seconds, right, because we have a negotiation protocol that's in play, right? We have PAgP. And now you can see what's going on here. We've got some spanning tree activity, right? Because we made these trunk ports. If I say do show interface trunk, it's very important to notice that the trunk mode is on because we said switch port mode trunk. But where are the member interfaces? We don't see Fast Ethernet 0, 21, and 22 individually listed out, just like we don't see that when we say do show span. We see the port channel interface, and you can see that's nice. We get the LS in, it shows we're in the listening state, and we know that this is going to be, and we only have VLAN 1 here, we know that whomever is going to be, if I think one of these guys, I'm not sure who's the root bridge here. Let's see, it says, I'm looking at the MAC address here. So this is not the root bridge. So this is our root port, right? And again, it's going to win that root port election because the cost on the non-root bridge is the driving factor, right? On the non-root bridge, the cost is going to be selected or be evaluated before the sender's port ID, which is that priority dot number value we see here. Okay, so again, that's why that's the root port. So let's come over to, and I'm sorry, we're on switch 1. Let's come over to switch 3 and let's see what this guy shows. Do show span, right? So all of these ports are designated ports. What does that tell you? It's a possibility. This is our root bridge, and all we need to do is look at the root bridge ID in the output here. We see it ends in 8494. We match it up on the local bridge ID, and yes, this is the root bridge. And when I say do show, what was I just thinking there? We've already done do show span. We wanted to do show, I apologize, it's slipping my mind right now, is the command I just wanted to run there. Switch 3, switch 1. And it was one that we ran over. Oh, do show interface trunk. I apologize. There we go. So I wanted to say do show interface trunk. And again, we see it's trunking. We've only got one VLAN, and we only see the single logical port channel interface. We do not see the members. Now, a command that isn't here, do show spanning tree. And actually, if I were to get out of global config mode and say show spanning tree and do a question mark, there's no option here because again, it's ether channel. We've got it's packet tracer. So we've got a limited number of commands. If I pull up a real Cisco switch, a very handy command and one that you should definitely keep in your CLI toolkit is do show spanning tree root. And this is a phenomenal command because it will show me for each VLAN, if I had multiple VLANs here, we'd see that. For each VLAN, what is the, and that's the, we see the root ID. So this is the root bridge ID. We see the bridge priority value with the VLAN added in, right? That system ID extension added in. And we see the MAC address of the root bridge. We also see the cost for us to reach the root bridge. Then we've got our timer values. And again, these timer values with the legacy PVST, PVST Plus are all set by the root bridge and the BPDU that the root bridge is sending every 2 seconds. And then we see the outgoing interface that we would egress to reach the root bridge. In other words, our root port. Now, we get a different look when I get onto the root bridge and I say, show spanning tree root. We get a different look here, right? And there's noticeably 2 fields that are strikingly different. The root cost of 0 and the root port is blank. And so when you run this command, and this command makes it very quick and very simple to take a look at the output and say, on a per VLAN basis, we've got VLAN 1, you may have VLAN 2, VLAN 3, VLAN 99, whatever VLANs you have, my pen stopped writing there, whatever VLANs you have, it's going to give you one line of output here for everyone, but it's going to show you your cost to reach the root and the root port out which you would egress to reach that root bridge. If the cost is 0 and there is no root port listed, What does that tell you about this switch for VLAN 1? Exactly, right? This is a gimme question here. It is the root bridge for VLAN 1 because the cost to get there is 0. I don't have any outgoing interfaces that I'm going to be egressing out to reach the root bridge, because if I did, I would have to add that as part of my root path cost, and there would be a port that I would be going out. And literally, you should be able to look at the root port column, and if there's nothing here, that you're the root bridge, right? You are the root bridge. Because if you weren't the root bridge, you would have to have a root port listed that you would be egressing out to reach that root bridge. And the possibility exists, I don't think I've looked at this before, but if you're thinking to yourself, well, what if it's just one switch all by itself? Well, then that kind of defeats the purpose of Ether channel and what we're talking about. And it might not show this either, because if you have a single switch, it is the root bridge for everything on that switch. And by single switch, I mean it's not interconnected to any other switches. So, but hopefully you get the point. And there's a lot of value in that command right there, show spanning tree root, that allows you to see on a per VLAN spanning tree basis, PVST and PVST plus, and we're doing PVST plus, right? Allows you to see very quickly what role does this switch have for the VLANs that would be listed out here, right? And you can quickly check things and validate your configuration. So that is a big plus from the CLI perspective. Let's get back to the activity here and show spanning tree again. It's not there. So we've taken care of the PAgP link. Configure the logical interface to become a trunk by first entering the interface port channel number. Oh, and I actually went out of order. I apologize. I put switch port mode trunk in there first, but it wanted us to do it under the port channel. So we will make that happen. So, okay, we've talked about the status. Now we're down. So that's PAgP, right? And again, as I said in class, always, 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 always use LACP unless you're being forced to use PAgP, and then only use the on mode if you would like to be looking for a new job at some point in the near future, right? And I jokingly kind of said that. And so let me qualify those statements. LACP is the open standard. It says 802.3 AD, and it definitely, people are going to know what you mean by that, but it's covered under the new 802.1 capital A, capital X. And you'll see there's a nice little footnote in the text early on in chapter 4. So 802.1 AX is where you're going to find the Ether channel standard defined today, but originally it was 802.3 AD, just like when we say 802.1 W. That now falls under 802.1 D 2004 or 2005. I can't remember, 2004, 2005. But again, it's no longer 802.1 W. It's been rolled under a larger standard. And so LACP is the open standard. That is the Ether channel protocol that you should be using everywhere, because you never say never, right? Never say that you will never have to Ether channel with a non-Cisco device. You always want to be using LACP. Again, it's the open standard, because the switch that you're Ether channeled to today could be a Cisco device, but tomorrow could be changing to a Juniper device or an Arista device or an HP or any other vendor other than Cisco. So it's a great rule of thumb. There's also another reason that we'll talk about when we transition back over to the physical switches. And that reason is that at the beginning of the chapter, you'll notice it said you can only have 8 physical interfaces in an Ether channel bundle. And as I was reading the chapter, I stopped immediately and I said, I really, really hope that later on they clarify this when they break it out into the PAgP and the LACP portion of the discussion, because PAgP can only have 8 interfaces, whether active or inactive. 8 is the maximum with PAgP on the Catalyst side of the house. LACP, right, the Link Aggregation Control Protocol, we can have 16 total interfaces, 8 of which can be active at any time. So in other words, you could have up to 8 replacement or hot standby LACP interfaces ready to go if one of the 8 active were to fail. And so keep that in mind, right? That is another advantage, especially if you're in an environment where you've got, let's say it is fast Ethernet interfaces, and you've got maybe hundreds of hosts sitting behind that LACP Ether channel of 8 fast Ethernet interfaces, and you're, on a wing and a prayer there with 800 megabits a second available. If one of those links goes down, that could seriously impact performance for you. And it could seriously impact, you could start to have congestion on those links, because all of the traffic that was going across that link is now going to have to spread across the remaining 7 links. And maybe you had a modular chassis, and what you really had was this. Maybe it was a modular chassis that you were using, and 4 of the links were on that line card, and 4 of the links were on that line card. And that line card goes away. So if the other 4 active links were on these line cards here, you're now down to you just had a 50% reduction in the aggregate bandwidth that's available. But with LACP, if you did 4 here and 4 here, as well as 4 here and 4 here, right? That line card goes away. These 4 guys are offline. Hey, no worries, boom. These guys jump right in and pick up the load, right? And you're protecting yourself against multiple line card failures in this scenario. So again, it's going to come down to use case. It's going to come down to your specific use case, but these are all very important things to be thinking about when you're deploying Ether channel. And when you're picking, do I want to do PAgP or do I want to do LACP? Again, with PAgP, that is not a possibility of having all of these links in this hot standby state ready to rock and roll, right? With LACP, it is. We can pull all 16 links in there and it's ready to rock, right? Ready to rock. So give that some consideration when you go forward and you progress in your career and you're able to start to make some of these decisions as to how things are going to be architected. So LACP, and again, with LACP, it's active and passive, right? So making it simple, right, or easier, right? Active, passive. It's the synonym of active is passive, the synonym of passive is active, so it kind of keeps it simple. So here's what we're going to do. Switch 1 and switch 2, we're going to use the gig ports and do LACP. And this time I'm going to follow directions. I believe that everything we do is going to be done under the port channel interface. So I will keep that in mind. Now, the port channel numbers are local. You can see we use port channel 1 here. And this is what we talked about in lecture. Remember, the port channel numbers don't have to match. Just like I don't have to use the same interface numbers. But think about this. If you have to troubleshoot this, do you want these interfaces, all 4 interfaces, to be different? And do you want the port channel numbers on either side to be different? That will be a dumpster fire to troubleshoot. So whenever you can, just like I said, always use LACP, because never say never. Always use, if you can, the same interfaces on both sides of the switches here, and always use the same port channel number on both sides. It's going to make it exponentially easier for you to troubleshoot. So let's get into switch 1. and we'll go from user exec to privilege exec into global config. I'm going to say interface range, and this is gigabit 01 and 02. We're going to shut them down right out of the gate. And let's go ahead and say channel group. Oh, whoops, I almost said 1. Channel group 2 on switch 1 here, mode, and it wants, and I got to pay attention because we're going to lose point. We're going to be getting torn apart here on point. So on switch 2, add that is the passive, switch 3 to detect. And I'm missing on port 1, use the channel group active. So we're going to say channel group 2 mode active, right? And that's good. It creates that for us. And then I'm going to go into interface PO2 because channel group 2, that number corresponds to the port channel interface number. So I'm going to say interface PO2, switch port mode trunk, and now we're good to go. I can even throw switch port no negotiate on the port channel interface. And if I say do show run, and we get down to those gig interfaces, take a look at that. Mode trunk, no negotiate, automatically push down to those interfaces for me. Let's pull up switch 2 for the first time. And on switch 2, the gig ports, does it say? I think it says we're going to use active there. I don't see it saying passive. So we'll go with active there and we'll see if we get the points. We'll get into global config. We need a host name, S2. So we should get a bonus point for that. We do. Interface range, gig 0122. Let's shut it down. Let's say channel group 2 mode active. So we make that. Yeah, we definitely got points for that. So it's definitely going to be active. Let's go into interface PO2, where I'm going to say switch port mode trunk, switch port no negotiate, and now I'm going to say no shut. And then let's pull back switch 1, and let's do the same thing. Let's bring those interfaces up. Now, what happens if I say no shut under the port channel interface? You'll notice that didn't help things. Do show IP interface brief. And this is important as well, because again, when we're talking about entering commands that get automatically pushed down, configuration commands that are required for functionality, right? But we're still administratively down. And the reason it's not going to do it for all of the interfaces is it gives us the option of going into individual interfaces and bringing those up. But we're going to bring them both up. Interface range gig 01 to 2, no shut, right? And so it's still red. Why? Because when I was over here, I said no shut under the port channel interface. So interface range gigabit 01 to 2, no shut, and that brings that port channel interface up. So while spanning tree is doing its thing there, we've got other work on switch 2 here. Interface range fast Ethernet 023 and 24. I'm going to say channel group 3, right? It's got to be different than what's locally already defined here. Mode, and this is where it wanted me to do passive on switch 2. So we'll do that. And then on switch 3, we go into privilege exec, global config, interface range, fast Ethernet 02324. I'm going to shut these guys down. We're going to say channel group 3. I almost said 1. I make that mistake a lot and be very careful about that. Make sure that you're matching your channel group number so that the port channel interfaces are the same. So channel group 3 mode, it wants active over here, right? And you can see that's bumped us all the way to 91, so we're in pretty good shape right now. So let's get into interface PO3 and say switch port mode trunk, and then switch port no negotiate. We're not being asked for the no negotiate, but that's okay. We'll add that in, best practice, right? If we're going to hard code it as a trunk, we're going to turn DTP off. And same thing here, interface PO3, switch port mode trunk, switch port no negotiate, and that takes us to 99 out of 100. Right? So there's one thing that we're going to be missing, and it's going to got to be that that spanning tree root bridge action there. So Now let's say no shut, but wait, let's get under the right interface. Interface fast Ethernet 02324. Interface range fast Ethernet 02324. We say no shut. I go to switch 3, and we'll do this for dramatic effect so that we can see what happens with those red lights. Interface range fast Ethernet 02324. No shut. Brings the line protocol up, right? So we should see those transitioning to green here shortly. So this is going to make things significantly easier. And I'm getting concerned here. Yeah, it shows that it's up. I guess, okay, there we go. So it just took Packet Tracer a few seconds there to sort things out, because typically you'll see those lights pop up and Spanning Tree will start doing its magic right away. But it took it a few seconds there. So now we have port channel interfaces. And so these individual physical switch ports are now seen by all of the switches, and most importantly by the Spanning Tree Protocol, as a single logical interface, which means only one set of this output here, I should say one set of these physical ports, these guys right here, and actually, it looks like I didn't wait long enough for Spanning Tree, these guys right here are being transitioned into the blocking state because they both represent now a single physical interface, right? Single logical interface is what they now represent. So we look at this now as one of these guys has been elected as the root bridge, and then it was sorted out after the fact as to which single logical port channel interface will be blocked. And so let's see what that is so that we can work through this. So when I say do show Spanning Tree, I can't say show Spanning Tree root, but we see that switch 3 was elected as the root bridge. And we see that because all of the ports are designated ports, and most importantly, the root bridge ID matches the local bridge ID. So how would we sort that out? Let's talk about that root bridge election. Well, we haven't changed the root bridge priority yet, so everybody is 32,768 for the bridge priority. So then we have to go to MAC address. Well, we see the MAC address here for switch 3. Let me quickly go to switch 1 and say do show span. And let's go to switch 2, and we want to bring it so that we can see them all, and say do show span. And actually, I'm going to have to probably move this over here to get 1, 3, and 2 all up at the same time. So now we're looking at these. Let's walk through this. The number one decider is the bridge priority, but the default is 32,768 for everybody, right? And we can figure that out by looking at the priority that's set, right? So it's a push. So everything is equal. So then we go to MAC address, because remember, lower is always better in Spanning Tree, and there will never be a tie. So the bridge priority is 32,768 on everybody. We now go to the MAC address. So we see 0001 436E. 436E is what that looks like there. Let me clear that. Yeah, so 436E. So, I'm sorry, we're good here. 436E, I want to come down here. So 0009, 0001, 000A. So which is the lowest of all of these? Exactly. 1, who is switch 3. So switch 3 becomes the root bridge, which means that's a designated port, and that's a designated port, which means that this, right, this single logical port channel interface, that's the root port based off of the root path cost. Switch 1 says, what's my root path cost going that way, right? And we look at the port channel, you can see the different values, right? For the gigabit interfaces are different values, but from switch 1's perspective, the cost of this port channel interface is going to be 3. The cost here is 9, and the cost here is 9. So switch 1 says, my route path cost to get over to the route bridge, switch 3, going this direction is 9. What is it going this direction? Well, it's 3 because we have to add the outgoing interface cost. And remember, it's both of those interfaces together now, right? So it's 3 because these are gig interfaces and the port channel is 2 gig interfaces. And then I have to add in, I've got to come through switch 2 and his route path cost is going to get added in, right? On the egress is where we add things in. So 3 plus 9 is 12. So we're going that way. And then switch 2. Right? Same thing. My route path cost to get to the route bridge going that way is 9. If I swing around this alternate path here, the cost is 12. So winner, winner, right? Right there. So now it brings us down to this segment. And remember, every segment is going to have a single designated port that's going to be responsible for the forwarding of the BPDUs. The other side, right, when we've got a loop, the other side would become an alternate port. And we've got the answer down here, but let's talk about why. So we can see that on switch 1, and obviously they're orange as well, that becomes my blocking alternate port, but why? Why is that the alternate blocking port? Is it the route path cost? No, right? Because going this way, right, the route path cost coming up is going to be 12. I'm sorry, route path cost. Is it the route bridge ID? No, it's not the route bridge ID at this point. It's the route path cost. Because going this way, it's going to be 12. Going this way, it's only 9. Switch 2 sends a BPDU that says, hey, route path cost of 9. Switch 1 sends its BPDU, says, yeah, route path cost is 9. And so then how does it determine it? Because the route path cost is the same. So then what are we going to end up looking at? We end up looking at the sender's port ID, right? Remember that? If the route path cost is the same from the BPDUs, then what do we look at? We look at the sender's port ID. Well, we've got switch 2 and switch 1. You can see switch 1 was 128. I'm sorry, we're going to be going out. Yeah, port channel 2 is 128.28. And on switch 2, it's 128.28. So we again have a tie. So what should have been the deciding priority, right? Is it route path cost? No. Is it the sender's port ID? No. It's who's sending the superior BPDU, and it's going to be the MAC address, right? 000A versus 0009. And that is superior, right? So the BPDU that switch 2 is sending will have a superior bridge ID. And I'm sorry, I wanted to talk through all of that, and I kind of got a little twisted there in what I was trying to describe, but I wanted to explain that the deciding factor, it's not going to be the route path cost here, right? It's not going to be the sender's port ID, right? It's going to be the sender's bridge ID. And the bridge ID is all about that MAC, the system ID extension, and the priority. And the superior the superior BPDU that's going to have the better sender's bridge ID is going to be switch 2. And that is why switch 2 ends up as the designated port, and switch 1 ends up as your alternate port. All right. So that is why we end up in that situation with those ports forwarding and blocking. And then the final point that we're going to need here, let's come over here. It wants us to set switch 1 as the primary with the, it says set the priority to 24576. Well, that's easy enough to do. We'll use the macro and we'll say spanning tree VLAN 1 priority, I'm sorry, not priority, that would be the non-macro. I would say root primary if we're going to use the macro. And then that gets us to 100 out of 100. So again, right, lots of options with Ether channel. And the final thing we're going to talk about is a best practice. And the book actually covers this. I was surprised they mentioned this. But when you're using one of the Ether channel negotiation protocols, whether it's PAgP or LACP, a best practice and a very smart thing to do is to say, under the member interfaces, we have do show run interface fast Ethernet 1033. So that's what we have now. Always a good thing to say channel mode, and you saw me doing this earlier by mistake. You want to, oops, sorry. You want to say channel, and channel protocol, not channel mode. Channel protocol, you want to lock in the configuration. So we used PAgP here, I believe. So I want to say channel protocol PAgP. And you're probably wondering, well, wait a second. You said that when we say channel group 1 mode desirable, that we're declaring it to be PAgP. And this causes a lot of confusion, these two commands here, right? Channel protocol PAgP and channel group 1 mode desirable. That is the only command that is required in order to have PAgP working. This is what we like to refer to as icing on your cake, right? That it's a nice to have. In fact, it's a great thing to have. Not required, but a great thing to have in a best practice, because here's what this prevents. You've got a junior administrator who you tell, go create me an LACP Ether channel, and you mistakenly give him these ports, FA 1033 to 36. He says, okay, great, I'm going to run and do that, Travis. Interface range fast Ethernet 1033 to 36. And you didn't give him that channel group 1 mode, or you didn't give him that channel protocol PAgP, or that wasn't already on the interfaces. He comes in and he says, channel group 2, or let's use one that we're not using, channel group 4, mode active, right? Take a look at what happens here. Because of the fact that we have this channel protocol PAgP command under the member interfaces, it is going to reject that command. And that is what we want. We're protecting ourselves from accidentally coming in here and using LACP commands on the interface. Now let's go over to the other side over here. Let's see what happens if that is not on the interface. Interface range fast Ethernet 1033 to 36, and I say channel group 5 mode active. Huh. Well, that's interesting. What did I just do? Yeah, I just took the entire network down. If, right? If that was it, if switch 1 was depending upon, and a little slow behind me there, if switch 1, let me clear that, we'll make this a little prettier here. And actually, we didn't want that. If switch 1 had those 4 links running over to switch 2, and they were all in an Ether channel that was PAgP, PAgP, and I mistakenly gave our junior admin these 4 interfaces, 36 is over here. Boy, the pen is failing me tonight. Gave it those 4 interfaces, gave the administrator those 4 interfaces and said, yeah, hey, run off and set that up for me and use LACP. We just took the entire network down while this was happening. Now, you're looking at this right here, right? And you're saying, oh, no, whoa, hold on. the interfaces are back up. Yeah, the physical member interfaces are back up. What about port channel 5? Do show ether channel summary. Let's see what we've got here. Yeah, so port channel 1, right? We know that's down because I destroyed it, right? I shouldn't say I destroyed it. I disabled it and took all of its member interfaces away when I said channel group 5, right? And you can see that here. But what did we not see a line protocol up message for? Yeah, we didn't see a line protocol up message for port channel 5, for PO5, because it is still down. So don't be fooled by what you just saw here at the tail end of me speaking. We're down, right? We are down right now. If I was to try to ping across do show IP interface brief, I think I still from the previous demo. Yeah, if I was to say do ping 10.0.0.2, guess what? We've got connectivity, but why is that working? And that's working because the other interfaces, there's other trunk ports. So let me fix that interface range. And I kind of walked myself into that one. And we said 36, so 37 to 48. I'm going to do FA, right? And I'll say shut. So I have effectively cut all inter-switch communication off, right? Because our port channel, our ether channel between these two guys is down. So if I say do show interface trunk, right? And I guess we're going to end up waiting here. And 35 because we crossed it. So what you would see, I'm going to have to physically, because it's still not correct, because remember, I switched 33 and 35. I crossed those Ethernet cables. So what you're going to see is that port channel interface, not only is the port channel interface not going to come back up, but the connectivity is gone, right? Because we're assuming we didn't have another way to get over there. So again, remember that. That's why that channel protocol command is a critical best practice, because it is going to save you from what I just showed you from happening, right? You tell your junior guy, hey, take those 4 interfaces, and you mistakenly give him the wrong 4 interfaces, and you don't have the channel protocol command protecting those interfaces from other aggregation protocol commands from being run from another aggregation protocol, you're down. All right, so big topic here, ether channel. Very, very important, and now we see why ether channel exists. It gets us away from having links that are being unused that run between switches. All right, thanks for watching, guys. Packet Tracer 4213 in the books. I will see you on Tuesday.